We want to find a basis for the null space of A for this 4x5 matrix A. So basically, yeah, it's the homogeneous equation, but in matrix form. So remember, null space is just the solutions AX equals 0. So we're going to do stuff that we've already done before. So I will do a bunch of row reductions to A. I'm going to move this row up to the top. And then in the next step, I'm going to do the subtractions right away to reduce the other rows. So this is going to be the 35520, but then I'm going to subtract 3 of the top row from it to get 0, 5, -1, -4, -3. And this will be 1 minus 1, 1 minus 0, 1 minus 2, -2 minus 2, and -2 minus 1. And again, this will be the fourth row plus the old second row. So it will actually, yeah, if I add 2 of that old second row, you see it'll just completely wipe out that fourth row. And same thing, I am going to now put the third row up to give me this. And now if I subtract 5 of this one from the other one, I am going to get 4, 16, and 12. So the number should look something to do with that other row. And let me just reduce that one to get 1, 4, 3. So I'm going through this row operations kind of fast because hopefully you're good at these by now. And then now I'm going to add this to the row above, and that's going to wipe out the 1, 4, 3 there. And then I'm going to subtract 2 of that 1, 4, 3 from this to get rid of the entry above. So I'll get -6 and -5. And so what's really nice about this is I don't even have to do much of a check. I know I've got my 3 pivots, so I will have 2 free variables, S and T. And so pretty quickly, this is going to generate my solution set. I'm going to move that over a little bit. So I'll have S and T, and then I can see that's going to be -4S minus 3T. This has no S's and T's attached. It's just 0, right? There's x2 has to be 0. And then this will be 6x plus 5t. And so just by construction, the arrangement is going to sort of force this to be linearly independent from the other one that comes from the t vector. So I get 1, -4, 0, 6. That's t, -5, 0, -3, 0, 1. And we can see basically because of the spaces where the S and the T were introduced, they're going to be just like 1s and 0s, and the way they form will make them totally linearly independent. So this is my basis for the null space. It's going to be these 2 vectors. And we are done.